I don't know quite what to say.
Now what we're going to do here is a demonstration, correct?
Right.
Okay, what are you going to do specifically? You're going to transmit energy from here, communications or signal from here up to the other receiver.
Well, first of all, we can show them the electric field off the top of the ball. And can you see that in the picture? The bulb energizing.
You'll notice that the bulb went off and then the bulb came on without even any energy, no electrical current going through the bulb at all.
You were just transmitting electrical energy through the air, in essence. What we're doing with this is trying to show the way that it could be utilized as the transmission of digital signals through the earth for what we're calling the new internet. And that, in doing that, we're going to be looking at there's another one of these, correct, in another spot.
Right, 1,000 feet from this point.
All right, and we're going to be transmitting through the earth with less than how many watts of power?
Between 10 and 12 watts.
Between 10 and 12 watts of power. So you're lighting up a 110 volt fluorescent tube with 10 watts or 12 watts of power.
Right.
With no wires.
Right, we can do it at night so it can be seen better.
All right.
Turn it on and off. Turn it on for 6 seconds and turn it off for 4 seconds. Repetitiously until we shut it off.
No.
Then we'll go down to the receiver and we'll observe the signal on a meter.
Now what we've done is we've walked about 1,000 feet from the front of the where the other unit is, and if you'll look, you'll see that it's quite a distance away from where we were.
This is the receiver coil, and it's primarily the same as the transmitter, except the receiver circuit. Well, this coil doesn't have a transmitter. It just has a receiver circuit on it. The other one just had a transmitter circuit and did not have a receiver circuit, just to show the principle. And here we're going to show the variation in voltage received when the transmitter is on and when the transmitter is in the off position. Right. This meter here is attached to the receiver circuit, and when the transmitter down there is in the off position, we're receiving 70 millivolts of voltage and approximately 110 to 120 millivolts when it's on. Ready? Alright, the transmitter down there transmits for 6 seconds, and then it's off for 4 seconds. So this low reading of 68 millivolts is on for approximately 4 seconds, then it jumps up to around 110 millivolts for 6 seconds. And if you just watch it, you can time it or count, and you can see that it's 4 seconds, and then it goes for approximately 6 seconds to the higher reading, showing that we're picking up that strong of a signal for approximately 1,000 feet.
We're not receiving. The transmitter is off. The transmitter is on.
This receiver circuit, one part of it amplifies the signal and then triggers these lights in the on position when the transmitter is transmitting. But right now I'm not using them. I disconnected the battery because it's not working at this moment. And we're just getting the direct signal that we're getting straight from the ground to this meter is what you're reading. It's just the direct amount of voltage that we're receiving with this coil.
Now you'll notice in this picture we've removed the batteries, and now we're going to focus on the meter, and you'll be able to see that the meter is still functioning. You see there's no power at all to the unit.
So what you've just witnessed is a transmitter transmitting for a distance of 1,000 feet and receiving a signal of approximately 65 millivolts, because the ground voltage is approximately right now 63 millivolts, and the transmitting signal is 133 millivolts. So the difference is approximately 65 millivolts that we're receiving at 1,000 feet with an input of approximately 10 watts.
Now we are behind the receiver. I'll give you a shot of how far the transmitter actually is. Now what you're looking at now is, earlier we showed you a picture where the light bulb was lit up using no electricity or no wires whatsoever, and what you're looking at now is actually the light bulb lighting up. The electric field is lighting the bulb, and so we're at night, so it's easier to see it. It's pretty impressive. You can see we're getting pretty far away from the transmitter.
Whoa.